Greetings, everyone. This is Jeff Wilkerson, professor of physics at Luther College, bringing you the next in our series of what to look for in the night sky. We're talking about the week of July 22nd this time around. We've been looking, so it's the moon starts pretty full. The moon's almost full to begin the week, 90-some% full, but it's past full, so it's going to be waning fairly quickly. So by the end of the week, it's gotten down to less than 40% full, and will allow us to see some other things in the sky. But it'll wash out most of the sky at the beginning of the week. We've been tracking Mars and Jupiter in the morning sky. And Mars starts the week 11 degrees away from Jupiter. So you find Jupiter as the big bright object. This region rises 2 o'clock-ish by midweek anyway. So you might want to be out 2:30, let's say, early in the week in order to be able to make sure this is above the horizon and to be able to see it. Jupiter will be the big, bright, white-looking object that's out there. Mars will be the red dot to the west of it. It's 11 degrees, a little over a fist width at arm's length away from it to start the week. It closes down to 8 degrees. So that's actually quite a bit of movement in 1 week, a few degrees. You might not notice that if these things were widely separated, but these things are getting close enough. These two planets are getting close enough to each other that you should be able to very readily notice that gap shrinking this week. It's worth watching as the week goes on. On the last day of the week that we're tracking here, the 28th into the morning of the 29th, we have the moon that's waned away to about 37, 38% full. We'll close in there, and we'll be sitting about 12 degrees. So this is when Mars is about 8 degrees from Jupiter. So about 1.5 the distance Jupiter to Mars will be the moon. This is fine. This is a great thing to see. It'll be good the next morning as well. We'll mention that next week. But this is a great thing to see here as the moon closes in. Now we've also, before we move on, it's worth tracking this. It's worth paying attention. Draw some sketches like this. Go out and sketch what you see and pay attention to this. This is going to keep going. You always look at this and you always think, well, remember, these are in prograde motion, moving easterly against the background stars. And you think, well, Mars might get over there and turn around and stop and start retrograde motion and come back the other direction. But it doesn't. And in a couple of weeks, 2 to 3 weeks from now, this is going to be great. Mars is going to close right down on Jupiter, and these two things are going to be right on top of each other. So this is something worth watching every clear morning, every chance you get when you're up in the morning and it's not light yet, to see where Mars is relative to Jupiter for the next month. This is going to be a lot of fun to watch. And so we've also been tracking Saturn, which is in retrograde motion, moving westerly against the background stars. And we've been tracking its progress, slow as it's been, against Phi Aquarii, a 4.2 magnitude star that we can see pretty well. We maybe didn't make the best choice, because we'll see by the end of the week what we're going to see here is that Saturn is going to be slipping south of Phi Aquarii, and it's actually going to get closer to Chi, which is a 4.9 magnitude star that sits south of Phi Aquarii. And so we want to watch this. By the end of the week, they're going to see a triangle of these objects. If you've got dark skies, a 4.9 magnitude star, you can see it. You'll be able to see what's going on there. If you don't, binoculars are going to help you quite a bit right here to see these objects. But at the end of the week, this same 28th into 29th morning, the Saturn will be sitting just less than 1 2/3 degrees from Phi Aquarii and about 1.5 degrees from Chi. Remember, 1 degree is 1 finger held out at arm's length, the width of a finger like that. And so this is another thing to pay attention to over the next month or so, over the next several weeks, as Saturn slips this direction and sort of splits these two stars. And so these are close enough to each other now that you can really start to track that motion. If you want to, you can also start in the evening sky at the end of the week. I think it's hopeless at the beginning of the week. Maybe by the end of the week, with your binoculars, go out just after the sun has set. You've got the glow of the sunrise. Let the sun get out of your way. And as it's darkening up, scan that western horizon and see if you can start to see Venus appear in your binoculars. Venus is going to have a really close approach to the bright star Regulus coming up here. in a couple of weeks, but it's going to be in the glow of the sunset and hard to see. But if you start practicing now, start to use your binoculars and see if you can find Venus, a bright dot of light in the glow of the sunset. Now, as the week wears on and the moon rises later and later and later and is waning away, our evening sky, as soon as it gets dark, 10 o'clock at night, let's say, our evening sky is great for observing. And we've got the summer triangle there, Deneb, Vega, and Altair is our summer triangle. If we go about the same distance from Deneb to Vega down again, you end up in the bottom part of the constellation of Hercules. And the best known part of the constellation of Hercules that people normally notice is called the keystone. It's this trapezoid type shape that's up here, that is the body of Hercules. And I've confessed in these videos before that I sometimes have a hard time finding Hercules for some reason. It gets lost in a lot of stars. None of these are really bright stars. Zeta, in the bottom right corner, the way I've drawn this, in the bottom right corner of the keystone of Hercules, Zeta is the brightest star there, and it's a 2.8 magnitude star. And the rest of them vary down. This is 3.9 over here. And so the rest, that's the faintest. And so they're all between third and fourth magnitude, which is plenty easy to see. But there's a lot of other stars around here. And so it can get lost in this sea of stars. But if you just drop down here and then move up, and you can bump into that keystone of Hercules pretty well. That's the way I try to find it now. If I don't look up and see it immediately, that's what I look for here. Now, a couple of things to observe here. In the western half of that keystone, the western half of that trapezoid, M13 sits right on the line that connects these two stars closer to the top star. M13 is the very best example of a globular star cluster in the northern hemisphere. And so binoculars will pull that out very easily. A small telescope, it's spectacular. Lots of stars, big and beautiful in the telescope eyepiece there. If you go up this direction from the east side, of the keystone, and move up about that far and then over just a little bit, you've got another very fine example, M92, of a globular star cluster. And if it weren't for M13 sitting so close to it, it would be better known, I think, as a good globular star cluster to observe. So to go out, we've been talking about globular star clusters every week. Summer's the right time to see them. I think I promised you last week we would stop talking about globular star clusters here soon. There you go. I can't help myself. These are these clusters. There are 500,000 stars or so in each star cluster, and they're in orbit around the center of the galaxy. And we can look toward the center of the galaxy. It's down here in Sagittarius and Scorpius right now. And we can look toward the center of the galaxy really well right now. So summertime's the right time to see these. And they're big and bright, a lot of them. Big. There's so many stars there. They're often very distant, but there's so many stars they're relatively easy to see. So if you've got a small telescope, this is great. If you've got binoculars, you can see it. You might be able to see M13 without any optical aid under really good dark conditions. I don't think I ever have, but I won't guarantee that. This star Zeta that we have circled there, bottom right of the keystone, this is a fun star because this is a binary star, and it's a binary star that's really close to us, 35 light years away. And so at 35 light years away, that's close for us as these stars go. And this is a star. So a long time ago, William Herschel was trying to measure trigonometric parallax, stars jumping back and forth relative, nearby stars jumping back and forth relative to more distant stars as we orbit the sun. And so he wanted to see this parallax that was ongoing. And he started to look. He figured what he would do is he would look for two stars that were really close to each other in the sky. And if one was fainter than the other star, he would assume that was quite a bit more distant. And he would look for the brighter star to jump back and forth relative to the fainter star. Not a bad idea, but it didn't work. And the reason it didn't work is because almost all of these really close pairings he found, and Zeta Herculis is one of these, were actually binary stars in orbit around each other, and they were the same distance. It's just one star was much less luminous, so it looked farther away to him. And so he got disgusted when he realized these stars were orbiting around each other. He was frustrated and disgusted that he wasn't going to be able to use these to measure parallax, and yet these stars that he discovered a couple of centuries ago, more than that now, these stars that he discovered are the backbone. Well, these are the stars that allow us to measure the masses, because we've seen a lot of these systems that he discovered all that time ago are just now completing an orbit around each other, and we can measure the masses of the components of these stars very well, and that tells us how stellar brightness depends on mass, and what we can just really, our stellar astrophysics, this owes so much to these observations of these binary stars. And this is one of these. One of the great things about Zeta, so we'll stop blabbering here soon, but one of these great things about Zeta Herculis, it's really close. And it's got an elliptical orbit, and so it only gets about 1.6 arc seconds, the two stars at their farthest point apart. And that's hard for a small telescope to see with the turbulent atmosphere, but I'm going to recommend you try it. And this is a very interesting one, because this is one since Herschel's time that we've seen complete orbits many times, because it has a 34-year period. So every 34 years, the stars close up and open up and close up and open up. And this 1.6 arc seconds is a real challenge, but maybe you can see these start to separate here as two blobs of light. And 2024, right now, we're at the farthest separation. So this is the time to go see it. If you want to see this star as a double star, as a binary star, you're not going to have any better time than right now. So I'm going to recommend that in addition to these globular star clusters this week. Always the planets. The planets are great right now. So keep tracking their motion relative to each other and their motion relative to the background stars. Watch for the moon to close in on Jupiter and Mars in the morning sky, and keep tracking Saturn's retrograde motion relative to the stars in Aquarius. And that's what we got for you, everybody. It's a great week. It's always a great week. And as always, thanks for watching. We'll have something new for you next week.